Friends, in today's lecture we are going to see different numericals on three moment theorem. We are going to solve the continuous beam with different types of loading by using a three moment theorem. Yesterday we have seen what is meant by the moment theorem, how to apply it for the continuous beam. We have solved numerical also. Okay, so we will continue with the same topic. We will solve some more numericals. Okay, so this is the beam. This is our first numerical of today's lecture. Calculate the reactions RA, RB and RC and draw shear force diagram and bending moment diagram for given beam. Shear force diagram, bending moment diagram is the common question in structural analysis 2 subject. So if you see the university question paper, you will get this sentence, draw SFD and BMD or draw BMD in almost every question. Okay. So this is the continuous beam which is carrying a UDL. One is of magnitude 60 kN per meter for A to B and second is of magnitude 100 kN per meter for B and C. From B and C. From B to C it is 100 and from A to B it is 60. Okay. Now we have to draw SFD and BMD and we have to calculate the reactions. Okay. Again, here also we have to apply theorem, three moment theorem TMT, that is MA into L1 divided by I1 plus 2MB into L1 divided by I1 plus L2 divided by I2 plus MC into L2 divided by I2 is equal to 6A1X1 divided by L1 I1 plus 6A2X2 divided by L2 I2. 6A2X2 divided by L2 I2. Okay. Again, in same like previous examples which you have seen in last lecture. First of all, we will find out each and every term in this three moment theorem. Okay. So let us start with the MA and MC. So now MA and MC, it's support moment at A and support moment at C. Again A and C both are simple support, means either it may be a hinge or roller. Okay, as we have seen there is only one vertical reaction. So A and C both are simple support. It may be roller, it may be hinge. So definitely the support moment at A and C will be 0. Okay, so MA and MC will be equal to 0. Okay. Then L1 is 4 meter, L2 is 6 meter. Now I, moment of inertia, again it is not given, so we will assume that moment of inertia is constant throughout the beam length. So here also moment of inertia is same, here also moment of inertia for BC and is same, I. Okay. So this term I, moment of inertia, will get cancelled from all the terms. This I in every term will be cancelled. Okay. Now what is remaining? So remaining is 6A1X1 divided by L1 and 6A2X2 divided by L2. Now L1 and L2 is known to us. Now what is A1 and A2? What is X1 and X2? A1 is the moment of A1 is the area of free bending moment diagram for AB span and A2 is the area of free bending moment diagram for BC span. Okay. So we have to draw the free bending moment diagram first. So now free bending moment for AB. So first of all free BMD for AB span. So free BMD for AB span is now simple. It is simply supported beam carrying UDL. What is the formula for bending moment? Maximum bending moment will be WL square divided by 8. WL square divided by 8. See, yesterday the point load was there. So for point load, free bending moment means if the simply supported beam is there along with the point load in between the span. So free bending moment, maximum bending moment will be WAB divided by L. Now here the UDL is there. The UDL is the formula is So W is 60, L is 4 square divided by 8. Okay, similarly, and this will be a parabola. This will be parabola. No, that if the UDL is there, then the parabolic curve will be there for the bending moment diagram. Then 3 BMD for DC span. Again, same formula, W square divided by 8. Now here W is 100, L is 6 square divided by 8. So this is also parabola. Okay, 100 into 6 square divided by 8. If you calculate this, you will get this as 450 kilonewton meter. Okay, and this if you calculate 4 into 4, 16, it's 120 kilonewton meter. Okay, so A1 and X1 calculation. So A1 is the area of this parabola. So this area of this parabola will be 2/3 of base into apex of parabola. So apex of parabola for this is 120, and here the apex is maximum bending moment 450. So area of parabola will be 2/3 of base into apex. Okay, area for this parabola is 2/3 of base into apex diameter. So 2/3 base is for first 4 meter and it is 120, and A2 again same 2/3 6 into 4. Okay, now what is X1? X1 is the CG of this diagram from A, and X2 is the CG of this diagram from C. See, yesterday I have told you CG of left side support bending moment diagram will be calculated from the left support, and for right side span you have to calculate the CG from the right support. Okay, so X1 is from this and X2 will be from this point. Okay, so X1 will be, now see, this is a symmetrical parabola, so X1 will be exactly at the center. As it is 4 meters, so X1 will be 2 meters. Simple. And for X2 again, as it is 6 meters, so X2 will be 3 meters. So calculation of X1 and X2 both are not so difficult as like in the case of point load, eccentric point load. Okay. Now all the values are known to us. We have to just substitute the values in the 3 moment theorem equation. Okay. So first term MA is 0, so entire term will become 0. Plus 2MB. Plus the I is get cancelled from all the terms. Then L1 is 6 meter and L1 is 4 meter, not 6. L1 is 4 meter, L2 is 6 meter, so 4 plus 6 is 10. Plus again MC is 0, so entire term will become 0. Then 6 A1 is 2/3 of 4 into 120, and X1 is 2 meter, divided by L1 is 4 again. Similarly for 6, A2 is again 2/3 of 6 into 450 into X2 is 3 meter divided by 6. Okay. If you solve this, you will get MB is equal to 318 kilonewton. If you solve this term, you will get MB is equal to 318 kilonewton meter. Okay. Now this is your support moment in. This is your support moment AB. Now see, suppose this is the beam. This free bending moment will be moment which is caused considering a span as a simply separate span. So this is a sagging moment. हा जो moment आपण दाखवलेला आहे हा moment कसा आहे sagging आहे. So it will bend the beam in sagging direction, in downward direction. Okay? Because we are considering that each span is simply supported. Simply supported means like this, and loading is like this. So definitely it will bend in this fashion. Now, what about the support moment? What is the design of the support moment 318? So support moment is going to act like this for each support. Okay, so it means it is a hogging moment. It is hogging moment. So it is going to bend the beam like this. So its sign is exactly opposite to the free bending moment. Exactly opposite to the free bending moment. So if we are considering this as a positive, this support moment will be negative. Okay. So I will just superimpose here on the same diagram, free bending moment diagram. I will superimpose the support moment on the same free bending moment diagram. Okay. So what is support moment A? It is 0. Support moment A is 0. What is support moment C? This is also 0. What is support moment B? It is 318. It is 318, and again it is 0. This is minus. Okay, so this is our final diagram of bending moment. This is final resultant bending moment diagram. This is called a resultant bending moment diagram, which predicts actual condition of bending moment in the beam. Okay, so now if you try to read this diagram, see bending moment at this location is 0. Bending moment at this location, but at the center, here if you calculate the bending moment, here this 120 is the free bending moment and this is the support negative bending moment. Okay, so this remaining portion is your bending moment, not this entire parabola. Okay, now from this location to this location, see this negative bending moment is much more than this positive bending moment. So the resultant bending moment will be negative here. The resultant bending moment will be negative from this region to this region. Again, if you see from this point to again up to the point number C or point C, see this positive bending moment 450 is more than this negative bending moment. This is negative bending moment. See, this is 318 and this is 0. So in between there is a negative bending moment line. Okay, so here also the bending moment, positive bending moment is more than this negative bending moment. So here the bending moment is positive, here it is negative, and here also it is positive. So what positive sign says? Positive means a sagging bending, negative means hogging bending. So now if you try to draw a bending position of this beam, see here it is 0, here it is 0. If you try to draw a deflected shape of this beam, how it will deflect? हा बीम डिफ्लेक्ट कसा होईल हे जर आपल्याला बघायचं असेल तर बघा A पॉइंट ला बेंडिंग मोमेंट 0 आहे. Then from A point to this point, this particular point, the moment is हा पॉइंट तुमचा इथला. या पॉइंट पर्यंत बेंडिंग मोमेंट कसा आहे पॉझिटिव्ह आहे. पॉझिटिव्ह म्हणजे हा सॅगिंग डायरेक्शन डिपेंड. इट विल बी देयर विल बी सॅगिंग. ओके, त्यानंतर ह्या पॉइंट पासून ह्या पॉइंट पर्यंत इथे बेंडिंग मोमेंट कसा आहे निगेटिव्ह आहे. म्हणजे निगेटिव्ह बेंडिंग मोमेंट जास्त आहे. निगेटिव्ह बेंडिंग मोमेंट कसा आहे जास्त आहे. So 318 minus this value, this resultant value will be negative. So इथं परत there will be hogging bending moment. There will be hogging moment. And again from this point up to this point, there is sagging. So the beam will deflect in this fashion. Sagging, hogging, and again sagging. See, due to this reason, if you see the reinforcement in the RCC frame structure, the intermediate support or intermediate column at the intermediate support, a beam is provided with the extra bar at the top. Beam is provided with extra bars at the top. Now here extra bars at the top, what is the role of that extra bars at the top? This extra bars at the top means, see, when I am going to cause, beam is going to cause a negative bending moment, means like this. So definitely tension will be at the top and compression will be at the bottom. Means if support lagenge तो इधर tension top class है and compression bottom class है. If the tension is at the top, definitely reinforcement should be at the top. So more reinforcement is needed at the top, where at the support and at the intermediate support, especially at the intermediate support. Okay, if you see the reinforcement laid for this casting of slab, you will come across this. When there is intermediate support, definitely there will be extra bars provided at the top. The reason behind this is to counteract the negative movement caused at this support. This negative movement has to be counteracted by someone, and this role is played by the top extra bars. Okay. So this is about the bending moment diagram. So drawing of bending moment diagram is not just enough. You should read. You should be able to read the diagram. What is the meaning of this? Okay. Now, if anyone asks you what is the exact bending moment at the center of span AB, what is the exact bending moment at the center of span AB? So you must able to tell. See, this is not 120 because 120 is the pre-bending moment. Means 120 we have calculated considering the beam span as a simply supported, but it is not the case. The beam is continuous beam. Okay. So what is actual bending moment? Actual bending moment is this 120 minus this value. Minus this value means it is 318 at this junction and it is 0 at this junction. So means at 4 meter it is 318 and 0 at 0 meter distance. So what will be the negative bending moment here? So 318 divided by 2. See, it's interpolation. Here it is 318, here it is 0. So what will be the bending moment at this center? So definitely 318 divided by 2. So minus 318 divided by 2. So what is this answer? That is your bending moment at the center. Okay. So it may be 8, 318 divided by 2. So it may be 11 kilonewton. Maybe 11 kilonewton per meter. Okay, so this is how you should able to 318, 120. Okay, no, it may be, it is again negative. Not. So what one may be value? It may be negative, it may be positive. 120. If you calculate this 120 minus 318 divided by 2. So 318 divided by 2. So 159. It's 159. Okay. So 159 is minus 30. Here also the bending moment will be negative. As this is 318 and this is 120. So here also bending moment will be negative. Okay. So the bending moment for this resultant diagram or for the continuous beam, if you see and if you compare with the simply supported beam, so definitely the bending moment is less as compared to simply supported beam. Okay, because due to this negative bending moment caused at the center, this negative bending moment reduces the positive bending moment or bending moment in sagging direction. Okay, now how to calculate the shear force? So for that you have to calculate the reactions first. You have to calculate the reactions first. So now I hope that you are clear with the reading of bending moment diagram. So if you want to calculate actual bending moment at any position, you have to consider this negative bending moment and positive bending moment. Here suppose they ask to find out the bending moment at this location. Here the bending moment will be 450 minus this 318 divided by 2. So again 318 divided by 2, because this is also at the center. So 318 divided by 2 is 159. Okay, so 450 minus 159. So that is the answer for the net bending moment at this center. Net bending moment at the center of span of BC. Okay. So suppose there is multiple choice questions. What is net bending moment at the center? So it is not 450 or it is not 318. It is 450 minus 318 divided by 2. So what is 318 by 2 represents? 318 by 2 means a negative bending moment at the center, and this is positive bending moment at the center. So 450 minus 318 divided by 2 will be the net bending moment, actual bending moment at that particular location. Okay. आता ही डायग्राम आपण ह्या आपल्या पिक्चर म्हणून आपल्याला लक्षात आलेलं आहे की this is सेंट्रल असतो जी व्हॅल्यू आहे बेंडिंग मोमेंटची ती कशी आहे निगेटिव्ह. निगेटिव्ह बेंडिंग मोमेंट इज हायर देन दी पॉझिटिव्ह बेंडिंग मोमेंट. Okay, so now we will calculate the reactions. How will we calculate the reactions? Reaction calculation procedure is again similar to the previous example. So we will consider each span separately and we will calculate it. This is 60 kilonewton meter, 100 kilonewton per meter, 6 meter and 4 meter. RA, RC. Okay. So this is again moment is 318. This is also 318. Okay. Now we will take the moment at B. Summation of moment at B and equating it to 0. So RA multiplied by 4 in clockwise direction plus 318 also in clockwise direction minus 60 into 4 into 4 by 2 in anti-clockwise direction is equal to 0. Okay. So if you calculate this, you will get RA as 40.5. Okay. Then for the second span we will take summation of all the moments at C and equating it to 0. Sorry, at B again. Summation of all the moment at B and equating it to 0. Okay, so RC into 6 meter, this is anti-clockwise. Then this 318, this is also anti-clockwise. Now here I have taken anti-clockwise plus. So this 100 into 6 into 6 by 2, this is clockwise. So as I have taken anti-clockwise positive, so clockwise will be negative. So if you calculate this RC value from this, you will get 247 kilometer. Now what is RB? So RB is again, if you take summation B, you will get RB. Means total load minus RA minus RC, you will get RB. It's a simple. So 60 into 4 plus 100 into 6 minus RA minus RC, it gives 550 552.5. Okay, so this is value of RB. Now RA is 40.5, then RC is 247 and RB is 52.5. Okay, now we have to calculate the shear force diagram. I will rub this. Now for shear force, simply you have to do the summation of all the forces. Okay, what is the definition of shear force? It's a summation of all the forces either on left side of the section or on right side of the section. So we'll start from RA. So start from A. So shear force at A will be, now A left will be 0. Shear force at A right will be RA, which is in upward direction, so positive 40.5. Okay, then shear force at RB, so B left means at this junction without considering RB value. So 40.5 minus 60 into 4. इतने RB कंसिडर केले नहीं है because shear force is at left. Now shear force at right. B right. So now here I will consider RB. So 40.5 minus 16 into 4 plus RB 552.5 plus RB because it is positive. Then shear force at C left without considering RC, and with considering RC, then that is our CF SF, shear force at C right. Okay, so now 40.5 minus 16 to 4 plus 552.5 minus 100 into 6, and here 40.5 minus 16 to 4 plus 552.5 minus 10 into 6 plus RC 247. Okay, so if you calculate, so shear force here it is 1995 9.5 and here is 353, then here it is 247 and here it is 0. Okay, so here it is, this minus, this is minus, okay, and this 247 is also minus. So here it is 0, then 40.5, 0, then 40.5, then minus 199.5, means minus 199.5. Then at the same point it is increased to 353, then again it is decreased to 247, and then it is 0. Okay, so this is shear force diagram. Okay, so now see, excluding three moment theorem, other parameters, other calculations are same like our structural analysis one. Okay, what is new part? New part is our three moment theorem. Okay, so that's it for today's lecture. In next lecture we will solve one more example on the three moment theorem. Thank you.